So in chapter 4, so far, 7.1 to 7.4 was just adding and subtracting fractions with algebra, adding and, or multiplying and dividing fractions with algebra, and now we're putting an equal sign into the situation. So we're making it an equation. So in 7.3 and 7.4, you would have just had this. Can you add those together? And the answer is yes. How do you add fractions? You need a common denominator. So if we were going to try to solve this, the solving, notice right here, they went with that common denominator idea. Surprise, surprise, we're adding fractions. But what I really like, and my favorite way to solve these questions, is I got a common denominator of 12x here. I got a common denominator of 12x here. And notice I also got a common denominator of 12x there. And if you get, and I'm going to highlight them here, if you get that denominator all the same, so here, here, and here, technically I could add these, they added the first two here. I might even skip this step. Because what happened from here to here? What mathematically happened?
Multiply by 12.
They multiplied by 12x. And if you multiply by 12x, those get to go away, right? In fact, we could have even done it the step before and had them all go away earlier. And what do you get? You get 20 plus 3x equals 36. And you change it from an equation where you have fractions to an equation that doesn't have fractions anymore. In fact, right now, we're back to, from this point on, it's grade 9 math. Combine like terms, get x by itself, perfect. So if we look at the second example too, they did this. I'll pull out my highlighter. I had an equation. I got a common denominator. And once I have that common denominator, I could multiply both sides by that and go, and it would just go away. Isn't that nice? And now we've got a grade 9 question again. So solving rational equations, the easiest way is to get a common denominator, and then you can multiply both sides to get rid of it.
What's the hardest way?
Sometimes people do like step by, like only get a common denominator on one side and then have to multiply the other side. That still works, right? There are some shortcut ways. There's some teachers that like adamantly say you can never use the shortcut because the shortcut only works in certain situations, and they're frustrated when students try to use the shortcut in other situations. This one has a shortcut way. The shortcut way for this one is if you have a fraction equals a fraction. Like I have 6 over x plus 2 equals 4 over x minus 4. I could multiply both sides by x plus 2, which would just move the x plus 2 over there. And I can multiply both sides by the x minus 4, which would just move the x minus 4 over there. And this method even has a name. Some math teachers curse the name. It's like, they say, oh, just use cross multiply. Because you see how I cross multiplied? I put the x plus 2 across to the other side, and the x minus 4 across to the other side. That's a shortcut method, but only works when a fraction is equal to a fraction. And some teachers are like, can't teach that shortcut because guaranteed someone's going to use it when they're not allowed to, and that'll frustrate me. And depending on the level of frustration, some teachers like, cross multiply is worse than swearing.
Feel it that they're frustrated. Yeah.
Okay. So, what do we have? What have we been doing we have been solving, so this is on your next page there. We have been solving rational equations. Okay? Something I want you to highlight though is that in solving rational equations, you have to recognize that there are non-permissible values, and sometimes those non-permissible values might try to sneak themselves in to say, hey, I'm an answer to this question too. But then you have to be careful, like, no, you were not allowed right from the beginning of this question. So if you try to be an answer, we have to say, no, you're not one of the answers. And those sneaky answers have a name. They're called extraneous roots. But we're going to use this strategy of getting a common denominator first for everything, and then you can cancel it out because you could multiply by that. That is systematically the easiest way. You're still allowed to do all the math that you've always done. If you want to do it in it, like combine something first and then do different, multiply both sides by a little bit and then a little bit more, you can, it's not wrong. But I think this makes it the easiest. And so one of the things that I try to do when we're learning stuff is I try to provide you with a way that makes sense and also makes your life easier. Because math is hard enough, right?
Trigonometry.
I don't know. I don't know if I can believe you anymore.
You have to listen to that.
So I'm going to rewrite everything. I'm going to leave space in front of those two and space after this last one. And in solving equation, and maybe we I'm going to even write it down at the top. Our solving rational equation strategy is to first get a common denominator. So I look at the three things in my, three terms in my rational equation here. What would the common denominator be?
10x.
10x. So the first one is just missing a 5. The second one is missing a 2x and a 2x. And the third one already has 10x.
Just missing the 1. If you want to be.
So I would have 5 over 10x minus 4x over 10x equals 1 over 10x. And once you have that common denominator,
You can use the Star Wars.
you can use the Star Wars sound. You can multiply both sides by 10x, which would simplify with the denominator and just go away. Which is really nice. And I'm left with 5. Did I? No, I didn't make a mistake. I thought I did. 5 minus 4x equals 1. At this point, you've changed it into a grade 9 question. Life is good. I combine my like terms, move the 5 over, divide by negative 4. I get x equals 1. Now, next time I'm going to do this right away. What is our non-permissible value or values in this question? What can x not be? 0. Because it could be that the answer that we show up, we have to check it with the non-permissible values. This one checks out. It's not 0, it's fine. We're done. But sometimes an answer might appear that was one of our non-permissible values. We have to be careful for that. Okay, you have to admit, A little bit fun? Huh?
I can.
Yes?
Next question is this one.
Next, well, we have to do B. It's
That's what
got,
I'm saying.
it's really fun. Oh, I think right, because it's quadratic?
We get a factor.
Oh, factoring starts with F.
Oh, fuck.
What else starts with F? Don't answer. Okay. For B,
That's where it was. I want to see.
5 over x plus, I'll leave some space in front of that one, equals 6. What is your common denominator?
X squared.
X squared. So we need to multiply this one by x and x. This one, which is over 1, right, would have to be multiplied by x squared and x squared.
We have to multiply the 6 over x squared by 1.
And we would get, oh, I want to stay with 5x over x squared plus 6 over x squared equals 6x squared over x squared.
So,
Multiply everything by x squared. And keep struggling to go back to 5x plus 6 equals 6x squared. And you're right, it's a little bit harder because it's a quadratic. How do we solve quadratic equations? We have to factor, which means you have to make one side equal to 0. So we're going to have 6x squared minus 5x minus 6. And you're right, this is a trickier one to factor. We,
I have no idea.
It's either 6 and 1 or 2 and 3.
it's 2 and 3.
10 different things.
Just
2 and 3.
not 10, but
There's a lot of
There-
things. 2 and 3, 2 and 3 twice.
right. 6 and 1, 2 and 3.
It's 2 and 3.
It's 2 and, so you try one. Let's go with 2 and 3. We need our outside and inside to make 5. If you use 2 and 3 again, you see their inside is 9, outside is 4. 9 minus 4,
Negative 9.
5. And we want negative 5, so we would need the 9, the inside to be negative, the outside to be positive. What could you do if you're shaking your head because that was too much for you?
Okay. Can I answer?
Yes. Oh,
What did he say?
Not again.
Oh. I thought that was just trigonometry.
he found out when he really hates a unit, he does well on the test. So he's trying to hate this unit, but he's struggling because he's liking it so far. Okay. You could use a quadratic formula. Right? You don't like to factor? Well, that's hard to believe, but if the factoring you're stuck on and you're getting a little bit frustrated, because this is a harder one, go to your quadratic formula. Plug things in. Yes, this might have some big numbers, like 6 squared is 36, but you could do it. Yes.
Once we're finished with what is that, are we gonna review the previous chapters for the final exam?
Yes.
Okay.
And you're reviewing them already because you're working on your
Yeah,
belts.
but like
Four
more
more?
helps more, you
A
know.
little bit.
Yeah.
So again, our non-permissible value in this one was x can equal 0. That's neither of those, so it works out. Okay, circle, questions 3, 4, 5, and 8.
So do you recommend doing the